really quick, if you have a distraction out, please put it away. Phones, books. In one of my classes I have to say boyfriends because it's gross, but whatever. No, but they're very like, hold on, pause. Okay, anyway, moving on. Okay, so if you know how A affects the graph, how H affects the graph, how K affects the graph, you'll be using those same sort of transformation rules for the functions that you see for the rest of this year and next. If I change that to a cube, the shape of the graph changes, but the way A, H, and K affect the graph doesn't. If I change this to a square root, the shape of the graph changes, but the way A, H, and K affects the graph doesn't. So if we can learn how A, H, and K affects the graph, it makes everything else a lot easier. So, let's first start, now introduce this in the whiteboard, so let's first start with this movement. So I have -5 here, would the graph shift up, down, left, or right? If that was a -5, it would go, say again, right, good. If you also thought right, you can give yourself a point. It would go right 5. And then that +3 would move up, down, left, or right. Plus. If you were to make a general rule, anytime it's inside with the x, regardless of what goes here, if it's a square root, if it's a half root, if it was a cubed or a fourth or a 27th, you always go the opposite, left or right. If it's a -3, I go right 5, or right 3. If it's a +3, I go left 3. Okay, but it's always the opposite if it's in with the parentheses. If it's outside, like this, it's +4, this -3, this is my up and down movement, and you do exactly what it tells you to. So this +4 means it's moving what? Up 4. This -3 means down 3. Exactly the way it tells you to. So, and then the shape of this graph, because of the 2, the shape is a parabola. Alright, so looking at example 1, without graphing, what can you say about the following? So this -2 means the graph has moved what? Right, 2. Up 2. Another name for move is shifted. I really don't care if you use the word move, but just know that shifting is another way I can say that. Okay, cool. What about the next one? The x plus 5 squared. The graph has moved what? Down, left, right. Left, right. Good. No, I don't know that. That's left. So that middle one is left 5. And what about the last one? So this is, sorry, this one's left 5. This one is, because it's -12, right 12, down 9. Okay, cool. What about this next section? These are words that we used last unit. Stretch, compress, reflection. If it's been stretched, all of these are dealing with the A value. Right? If it has been stretched, that means what with regards to A? Okay, so stretch, A has to be what? Greater than 1. Good. And I'm not looking at the negative at all, I'm just looking at the number. If it's been compressed, that means A has to be what? So for the compression, A has to be between 0 and 1. For the reflection, A is negative. So let's put both of those together now and talk about the different transformations on this graph. So for example 2, describe the transformation. We're going to start with any sort of shifting. So that minus 2 plus 3. So it moves 2 to the right. 2 right. 3 what? Up, good. And then what does the point 5 do? And then it's going to compress. Good. What about the next one? The plus 5 means it's been moved 5 left. Good. And what about the negative? Flexing. Good. And then what about the next one? That minus 12, that minus 9. It's been moved what? 12 to the 12 right. 9 down. It's been reflected because of the what? Because of the negative. And stretched because of the 2. If you follow and feel good about that, go ahead and give yourself a point. It looks like, and I'm going to pass it out in just a second. On your homework, you've got 2 different functions that are kind of mixed together, and somehow I lost part of this page. You have 2 functions that are mixed together. If you look at number 2, can you see this? If you look at number 2, you have this something squared. If you look at number 4, you have the absolute value mark. So the shape on number 2 is a parabola. Your homework doesn't ask you for the shape. I want you to. So I want you to state the shape of the graph. And then I want you to describe the transformation. So that's a parabola, I know because of the square. This one, we haven't talked about it yet. We know this one is an absolute value. I know because of these bars. So that's the first part. On number 2, this plus 4 means it's been moved 4 to the left. Left, because of this. And 4 up, because of this, right? Okay, cool. Let me pass out your homework. Pause. All right, let me do it again. Because of what? The square, good. And I know it's an absolute value because of the bar, the straight line. So let's talk really quick. Well, first of all, I think we've answered this question before. Can a function be stretched and compressed at the same time? No. Right? I can't have a 1/2 and 2 at the same time, right? What about stretched and reflected? Can that happen? Can it be stretched and reflected at the same time? Yeah. Okay, now we're going to talk domain and range. We've kind of brushed over it because I just simply forgot to talk about it. So now we're going to talk about it in detail. You're familiar-ish with domain range though, right? You've done it in previous classes. So this shouldn't be anything new. But just in case, let's define it one more time. Sometimes it's really hard to understand at the beginning and your brain is more developed now, so maybe it will make better sense to you. Domain is defined as all possible x values It's the input. If you're looking at a graph, it is all the x values your graph covers. Now, for a parabola, or an absolute value, parabolas look like this. This is your left and right movement. Technically, on a parabola, how far left does it go? Does it go left? Does it go left forever? Yeah, like it's going up, but it's also going left as it's going up. So on a parabola, the lowest point would be negative infinity. What about right? How far right does the parabola go? It goes right forever. So we're only dealing with parabolas and absolute values. For both of them, the domain will be from negative infinity to positive infinity. The range is what's different here. Range is defined as all of your y values. So you're going to put in an x value and then you'll get a y value out. This is your output. It's why we only multiply the x by 2 or the x by 3, because what we're getting out. The domain is stated from left to right. The range is stated from bottom to top. Now the range on a parabola can change. This parabola appears to start at 0, and it goes from 0 to infinity, right? But if the parabola shifts down at all, is it still 0 to infinity? Well, now it's negative 4 to infinity, right? If it shifts up, is it still 0 to infinity? No, it's up, right? If it shifts to the right, does my range change? If it just simply moves to the right, so this is my current graph and I just move it to the right, is the range still from 0 to infinity? Yes. So only the up and down movement will change the range. The domain will always be this. Okay, there are two different ways to state domain and range. The first one is interval notation. The next one is inequality notation. I prefer one over the other. I would say interval notation is the one that we use the most, but it doesn't really matter which one you do. On your homework tonight, you have about 11 graphing problems. On those 11 graphs, nope, technically, we only have 6 that really matter. Of those 6 problems, I want one of them to be inequality, one of them to be interval, the other ones I really don't care. You can choose which way you prefer. Interval notation uses these open parentheses and these closed brackets. This open parenthesis is called open, and you use them if the endpoints were not included in the set of numbers. For example, if I say the numbers from 0 to 1, it is all the numbers between 0 and 1, not including 0 and 1. Okay? So I'd use open parentheses if I'm not including the 0, 1. So 0.00001, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, they're all included, but 1 is not and 0 is not. The brackets are called closed, and you would use these if the endpoints are included. The endpoint is included. So for example, I have this bracket 5, 6, that's all of the numbers between 5 and 6 and including 5 and 6. So the biggest difference is, do I include the number or do I not include the number? Now, when I'm talking infinity, I'll always use the open parentheses. I'll never use infinity on here. With regards to range and what we're doing here, if I'm saying my lowest point is 0, does it actually hit the 0? Yes. So I would be, anytime I have a number, with regards to what we're doing here, I'm going to use the bracket. Put your pen away, please. Okay, now these match up. If I'm using an open parentheses, that means I'm using the less than or greater than. So inequality notation uses inequalities. The less than greater than will be used when an endpoint is not included in the set of numbers. If you wanted to say all numbers between 0 and 1, not including 0 and 1, you would write it like this. So really, we'll only use this when we're dealing with infinities. We will use this when we're dealing with numbers with regards to domain and range. Now the increasing, decreasing, when we did that, we didn't use the bracket at all. Because it wasn't increasing at that height or whatever. So for domain and range, you use the brackets if it's including the number, or the open parenthesis if you're dealing with infinity. So let's practice this. Before we start, let's just practice drafting the parabola. So first you want to look at your starting spot. Where's your vertex? The parabola is to be moved. Good. Left 4, down 3. Now the general pattern for a parabola is over 1, up 1, over 2, up 4, right? How does an a of -2 affect that graph? Right. You always multiply the ups, you never multiply the overs. Always the ups. So instead of going over 1, up 1, we're going to go over 1, down 2. If you're falling asleep, I'm sorry that it's boring. Go to drink and grab right back up and then come up. Okay, so I went over 1, down 2, and now I'm going to try to go over 2, down 8, but it jumps off the graph. That just means, oh, don't see that. Adorable. So this is what I want to do for my daughter's birthday party, because she wants a person's birthday party. It's a pinata with Moon Rider, and he's sitting with a pan. Isn't that cute? I know. So now I'm going to do yogurt to watch this. So adorable, right? Her birthday is on March 23rd, and her party is on March. This is crazy because my son turns 8 on March 16th. Her birthday is March 23rd, so her birthday will be the Saturday before on March 18th, and then have her birthday, and then her son is Saturday on March 25th. So it's going to be like birthday, back to the month. Oh, and the quarter ends on March 10th. Fantastic. Which means my dead day is a dead day. Like there's going to be no flexibility in March because I have a lot of family going on. Anyway, sorry. I only saw that because I have her right here and it came up, and so then I had to share because that's adorable. Alright, moving on. When my son turns 5, he had his Pirate's birthday party. Anyway. Okay, let's talk domain and range. For this one, let's do, it says to do it both ways, but that's kind of confusing. Let's just do integral on this one, and then we'll just do inequality on this one. You can practice both of them. And then you can decide which one you like better. So the domain. Does this graph go to the left? Yes. Does it go very fast? No. But this graph, if I were to continue to draw it, if I do it forever, will it keep going further and further and further to the left? Yes. So my domain is from -infinity. Same thing, does it go forever to the right? Not very fast, but does it go? Yes. So it goes from -infinity to positive infinity. A shortcut on how to write that is all real numbers. That R with the double bar means all real numbers. And you could use it instead of writing this. If you want. Or if you're like practicing your ugly infinity sign and you can do that. What about the range though? The range goes from bottom to top. So if I'm looking at this, that's the tipping point. I write up the top spot, down. So what's the smallest number? If I could hit the smallest number, what would it be? -infinity. Is that okay? So it's down forever. So it's down forever and then when does it stop? Any questions with domain and range on that one? The lowest number goes first. Yep, it always goes from small to large. If I see something where it's like 3 to -infinity or something, I automatically mark that wrong because -infinity will never be on the right spot. -infinity is always the first spot. It's always the smallest possible number. Okay, part B. Where's the starting spot here? Right one, down 2. This one takes on the regular parabola pattern because of the 1, right? So to get my next point, over 1 up 1, over 2 up 4, over 3 up how many? 9, I'm down 2. Right here. Parabola. I know it's a parabola because of this square. If it wasn't squared, it would not be a parabola. So let's talk domain range on this one. Now the domain, it goes left forever, it goes right forever. If I want to use interval notation, it looks like this. Oh, this thing is not, hold on. Negative infinity is less than x, which is less than infinity. That means my x values are between negative infinity and positive infinity. If you use interval notation or inequality notation, that's how you write it. It's the same as this one. You just put an x in there, right? Always with the domain. With the range, my y values, are they going to positive infinity or are they going to negative infinity? They're going up forever, right? So that means my y values are greater than or equal to, what's the lowest thing that the graph touches? -2. We'll practice both of those again. So, kind of a recap on the domain will always be this. The range, it just depends on what the smallest point is and what the opening is. This means right here, all of my graph, you can substitute that for graph. My graph is greater than or equal to -2, right? So how we get together and then we want it. If I already, yeah, it would be -2 infinity. If I wanted to do it the other way. Okay, let's do the next page. Okay, let's pause. Forgot to start my recording. Catch up. Pause it. This is where we're at. Okay, what about the range though? The range is from here down, right? So the lowest point is, okay, so it's negative infinity. My y values are what? Are they less than 1 or are they greater than 1? They're less than 1 or equal to. So if my graph is going down, that means I'm going to use a less than or equal to. If my graph is going up, I'm going to use a greater than or equal to. I'm sorry, I swear I explained that so much better in first grade. Are you with me? Are you okay? I hate that. Usually that's not true. Usually I do a better job in second period just because I've already done it once today. And we're screwed up. I didn't get it. Are you okay? -1? Yeah, I have that. Okay, let's go back to the notes. Now let's talk about the absolute value function. Before we start with the parent graph, let's just plug in some points and see what happens. If I have the absolute value of -3, what does that equal? 3, yeah. If I have the absolute value of -2, what does that equal? 2. If I have the absolute value of -1, what does that equal? 1. If I have the absolute value of 0, if I have the absolute value of 1, and then 2, and then 3, right? So what's happened here, don't draw this, just watch. What's happened here is I've taken my regular y equals x graph. It's really close to this one, right? But anytime my x was negative, it flips it to be positive, and that's how I get the shape. So it's like this part of the graph has moved in, that's where the v comes in, yeah? So here's how we graph it. At -3, I'm at +3. At -2, I'm at +2, +1, 0. And what shape does this one take? You can kind of use that pattern to get the rest of the... Because there is an actual graph that looks like a V. The more points you put on your graph, the better your line is. So I like to mark them all, but The rule is your graph should cover the entire grid, so the little arrow should be coming off the top. It's just because I'm picky. I like to see the whole thing. Yeah, right. Say it again. Yep. Yep. So the absolute value makes that V shape. The parabola makes the U shape. So the absolute value function uses the same transformation rule. Y equals A times the absolute value of x minus h plus k. The A is still the stretch, the A is still the reflection, the h is still the left and right, and do you think it goes opposite? Yes. And the k is still the up and down. This one, nope. Oh, so right here, can I get rid of all of those words? This is still opposite. This is still exact. It's exactly the same thing. The only difference is the shape. So the absolute value doesn't change the movement, it just changes the shape of the graph. Broadly viewed will be. So if I'm looking at this one, the first problem has been moved 3 what? Up? Has it been moved left or right? No. What about the 2? Stretch and reflect. It's been reflected because of the negative, it's been stretched because of the 2. But all the other rules are exactly the same. We're really supposed to be jumping out, so I'm just going to push through the end and then we can hear on it. What about this one? Is that x plus 5? Means left 5, up 2, and the 0.2 or 0.5 means things compressed. And then what about this last one, the minus 6? Right 6, down 2, and again using the same rules. It doesn't matter if the function is absolute value or parabola or cube or square root. All of the rules stay the same. The only difference is the shape of the disk, which we actually just finished talking about as well. I didn't very fancy words, so let's do more about that. All right, so let's graph each equation. The first thing you need to know is what that plus 4 does. Does it move it up, down, left, or right? Left, how many? 4. So starting spot here. I'm going to pause for just a minute because it doesn't take on the normal shape. Let's try part B and then we'll go back to A. On part B, where's the starting spot? Right 1, down 2. Now, A on this one is 1. The pattern for an absolute value, the slope is just 1. So up 1 over 1, all the way through. On the left, it goes up 1 over 1, so to the left. So it looks like it. The absolute value is what makes it have a V. The shifting is the same as the parabola. Just like those things. This where we know here. Yeah. Any preference for mine? Screwed up. Okay, what about the domain here? This one's a little bit easier so you can see that it goes less further, right? Because it's pointing to the left a little bit more than the parabola. Is it still from negative infinity to positive infinity? Yes. What about the range? What's the lowest point the graph hits? The lowest point is negative 2. What's the highest point? To infinity. Starts at negative 2, goes to infinity. Questions with that one? No? Okay, let's push through, almost finished. What about this one? We started at -4, but this time my A value is negative. So I'm outside of the parentheses, so I care about it. Do I go over and up, or do I go over and down? Yeah, I think it's down and over. Let's that backwards. But it's still kind of on the diagonal. This time I get that to come up. There you go. Other end, that looks like a check mark, and okay. What's the domain on this one? Let's write it in inequality notation. Negative infinity is what? Less than x, which is less than infinity. What about the range? Y is what? Now, is it going down or is it going up? Down. So my y value that the graph is covering is less than or equal to, what's the highest y value? 0. Good. All right, one more and then we're done. Let's see. Let's look at part D. This time, A is 3. Well, let's start at the starting point. That plus 4 minus 2. So left 4 down 2. What does the 3 do? The 3 is the slope. Slope is rise over run, right? Slope is the change in the y over the change in the x. So if I want to get my next point, I have to go up 3 over 1. I'm still changing my ups by 3, just like before. And you're up by 3 in both directions. It should look stretched. It should look taller. So, my domain, which one do you want to practice? Interval or inequality, do you care? You want to practice inequality? So my domain from negative infinity is less than or equal to less than x, which is less than infinity. You could have also put all real numbers. The range is from where to where? Y is it going up or is it going down? Up, so is that a greater than or is it a less than? My y values are greater than or equal to, what's the lowest y value? -2. Yep. All right, that's all. Thanks for watching. Peace out.